Alright, now we're going to cover Chapter 6, Firewalls and VPNs. We're going to do firewalls more than VPNs, but it's okay. And what's the quote? If you think technology can solve your security problems, then you don't understand the problems and you don't understand technology. Technology can be used to assist you. Again, it's like a control. It's not going to do it for you. Alright, you'll learn a lot of stuff in this one. Okay, let's talk about access control. First thing here, access control says methods by which systems determine whether or not to admit a user into a trusted area of an organization. So maybe we have a biometric lock on the door. Maybe we have a card swipe on the door. That's there to check who you are. On our forensics lab, we do have a biometric lock, and if your fingerprint's in the system, you put it on and let you in. If you're not in the system, well, the door either has to be unlocked for you or somebody else lets you in. Okay. Excuse me. A couple different types here. It says mandatory access controls. It says use data classification schemes. It's maybe it's top secret, maybe it's secret, maybe it's some sort of classification scheme, and you're only allowed access when you meet that criteria. Okay. Non-discretionary. It says strictly enforced version of mandatory access controls, but they're managed kind of like at a central authority. I'm trying to think of a. Hold on a second here. All right, let me try and explain this a different way. Okay, mandatory access controls is really the data. Okay, what is the data level? What do you need? What access do you need to access the specific data? Again, you might have read-only access to that data. You might have read and write access to that data. It really depends on the data. Okay, non-discretionary says strictly enforced by central authority. That would be the domain administrator. They have a security configuration for the entire domain, and because you're such and such, you get certain access. Okay. Discretionary says implemented by the discretion of the option of the data user. Excuse me, man, I'm dying this morning. Okay, and again, whoever's in charge of the data custodian at that point will give you access based on that. They do explain these a little bit better later on. Okay, identification mechanism whereby an unverified entity that seeks access proposes a label by which they know the system. Kind of like a kind of like a user ID. That's your identification or identification card. I drive on the Tinker all the time. I have an identification card. Okay. I can't really think of a better way to say that because that one's pretty straightforward. Okay. The supplicant is the entity that seeks a resource, so you want to have access to something. You want to have access to the data, so you be the supplicant there. Okay. Okay, it says identifiers can compose identifiers. Man. Concatenating elements, department codes, random numbers, student IDs even. Your identifier can be your name. It could be your anything. It could be a number. It could be pretty much anything. It says some organizations generate random numbers. Now there's issues when your identification is based on random information. A lot of people tend to forget it. Okay, so that's why it's normally your username kind of thing would be your name or your student ID, something like that. Okay. Authentication is the process of validating you or the person trying to access the information, the supplicant's purported identity. So you give me your username and password, and I authenticate it. Okay. A couple different ways. Obviously, we can use a password. Passwords can be anything from short to long to numbers to characters, the combination of all of the above. I access a website for the NSA for our certifications, and the password requirements there are between 12 and 14 characters long. Has to include 2 uppercase, 2 lowercase, 2 numbers, 2 special characters. The problem when you get to that point is it's hard to remember those things. You end up writing it down. Okay. All right. Could be a passphrase. I use a website. Let's see if I can't find it here. Let me pull it up for you real quick here. Hold on. Great, I hit the wrong darn button. Hold on a second. Okay, we're still there. Alright, now I'm going to show you an example of a passphrase here. Okay, I got a couple of web tabs open here. First one is LastPass. I use LastPass to store all kinds of stuff. As you can see, I have a lot of information stored in there. Well, with LastPass, you provide a password, but normally a passphrase to get all the stored information. Now, I also use Momengo. I did use Momengo exclusively. Now I use LastPass more. But with with Mamingo, again, you log in with the username and password, then you have to provide a passphrase. Then you access all your information again. This is what I used to use. It's still good. I just think LastPass is better. You can store things like, here's a bike lock. Yay! I used to ride a bicycle all the time, and I don't know where the bicycle is anymore, and it's locked up somewhere, probably. So there's the combination to it. If you ever find a random bicycle, that could be the combination. Now, and it used, actually, let me log out so you can see. Okay, so it comes up with my username and password, and then it wants a passphrase. Okay, this data is all encrypted with AES 256, so no one's going to be able to get to it. Okay, LastPass does the same thing. I could very easily log off and then enter my passphrase and get in. But again, that's the one I used more commonly now. So a passphrase could be a series of characters, typically longer than a password, from which a vital password is derived. Well, virtual password, not necessarily always, but a lot of systems are now going to passphrases, because rather than storing a random word, now they can have a long phrase. Mine's, what, 25 characters long, something like that. So. Oh, man, something in my chest here. Okay. Okay. Another thing. It could be something you have, like a smart card. A lot of the military ideas, I guess they call them cat cards, is really a smart card. It's a computer chip built into a card. You could have tokens, synchronous or asynchronous tokens. You could just, I walk up to my car. I have a fob in my pocket. It's really a token. I walk up to my car, automatically unlocks because I have the token in my possession. All right. Could be something you are. Okay. Relies upon individual characteristics. Could be like biometric. Could be fingerprints. Could be hand scan. Could be whatever. Okay. It's normally stronger, but we have issues with that as well. There was a Mythbusters episode about passwords and biometrics. You're using fingerprint scanners, and they had one that couldn't be broken, and they actually ended up breaking it by taking a picture of a fingerprint. So it was kind of funny. Okay. Authorizations is the match of the authenticated entity to a list of information assets and your access levels. So just because I have a login for the network, does that mean I have access to everything? No. I'm authorized certain access to certain items. And that should be checked quite frequently. So whenever I log into the computer system, whatever I try to access, they should be checking that. Okay. All right. It says handled in 3 ways. It says authorization for each authenticated user, which is correct. I can log in as a user, or I can log in as a group, or I can log in across multiple systems. Now, what they're talking about there, maybe Ken Dewey has certain access, but the fact that I belong to, I don't know, the faculty group, I get more access, which is actually true. I have access to my personal network directory, but being the fact that I'm faculty, I have access to student directories, so I can grade your work. Okay. I could also have access across multiple systems. I log into my desktop, but I can also get into a file server. I can get into other systems through that one login. There's also tickets, or the ticket granting server. That's kind of how Kerberos works in Windows domains. Okay. We have accountability. It says ensures that all actions in the system are authorized or unauthorized. Okay. It says can be attributed to authenticated identity. So once you're logged in, how do I know you have access to it? Or am I actually checking that? Okay. Normally we do that through logs, through journals, through auditing, through records. And normally, see, if you log in, you obviously have access. But what happens if you try to break into something, or you try to edit a file you don't have access to? That should be recorded in a log somewhere, so someone can find out what's going on. Okay. And there's lots and lots of logs. Okay. Now we're going to cover big part of the chapter, firewalls. Oh, man. Firewalls prevent specific types of information from moving between the outside world and the inside world, like the internet and an internal network, untrusted and a trusted network. Could be a separate computer, could be a service, could be an entire separate machine. We're going to see a whole bunch of them. Okay. A couple different types. Packet filtering, application gateways, circuit gateways, MAC layer firewalls, and hybrids. We're going to talk about each one of these in detail. Okay. Packet filtering looks at the header. It looks at where it came from, where is it going to, and what protocols it uses. Like it says here, uses IP or TCP, so it's looking at, where did it come from, what port are they trying to get in on, Like, actually, I can show you an example of that. Let me go over here, and I'm going to go to dewey.mine.new : let's go to 8080. Okay. I'm connecting to my machine. Now I specified the host name, which translates to an IP address, and the port name, this 8080 up here. And what that did, it connected to my home system on a specific port. My firewall then let me through. Now, so it's accessible from the outside world, but there's really nothing to overly worry about here. This is my solar system at home. I'm currently generating 496 watts, which is not a lot. But am I really worried about other people seeing this? I mean, you can see this, obviously. You can't affect it in any way. I mean, you can't take them offline. You can't do anything to it. But just by the fact that I know the username and the port, I was able to access it. And that's kind of what they're talking about here. Okay, the address, where it came from. Now, I allow anyone to see it. So you can bring it up from your house. So the destination is anybody? No, I'm sorry. The source is anybody. The destination is my system. And then the port is what, it directs my firewall to let you go to certain places. Okay, so simple firewall models enforce rules designed to prohibit packets with certain address or partial addresses. So we can get in and block specific addresses, like private address, like 192.168, or we can block 172, or we can block 127, or we can block invalid address, we can block all zeros. So there's actually a lot of rules for that, and you will see that in another class for sure. Well, you better see another class. All right, now let's talk about the subsets of packet filtering. We have static filtering, dynamic filtering, and stateful. Static says require the filtering rules governing how the the firewall decides which packets to allow are denied or allowed. That's it. Okay, you install them and that's it. It doesn't change unless you go in and edit them. Okay. Dynamic allows them to react to emergent events and update or create rules to deal with it. So something's happening, can change. Okay, so it allows the firewall to actually change its rules. Then we got stateful. Really what that does is doesn't allow anybody in. Okay, but if you go out, you can come back in. Okay, like I said, firewalls that keep track of each network connection between internal and external systems using a state table. Really, as long as you're go out, you can come back in. Like a row state, they pretty much block everything coming in. But then how do I surf Google? Well, what happens is I made a connection out to Google. Now, I made it out on port 80, but it actually comes back on a port at a higher number. So, that's how it connects. All right. And here's an IP packet structure. You will see this a whole bunch more in other classes as well. We have the version, the header length. Now, the version is like IP4, IP6, that kind of stuff. But actually, the header changes in IP6. Type of service, do we have identification, time to live. Let's talk about that one for a second. What's cool about time to live is, can you imagine a packet cruising around the internet with a bogus address? Just cruising around for forever. Can you imagine how much traffic there will be on the internet? So what they do is they set the time to live, TTL they call it. I don't remember a lot of things start at 0, some start at 64, but there's a limit. Every time a packet goes through a router, that number is decremented down to 0. When it reaches 0, it's done. So basically, the packet is dumped. That way, if you have a packet lost, it goes through enough routers, sooner or later it's going to be kicked off. Okay. Checksum, that's error checking information. That's actually changed in IPv6, but it is there. Then we have the source address and destination address. Let me show you what an address looks like. Some of you might not have ever seen one before. Okay, I'm on my machine here. I'm going to do IP config. Okay, got a bunch of different connections here. Now, we're talking about source and destination address. My address is this right here, this 10.60.203.2. Now, I also have an IPv6 address, which I don't know why it's enabled because we don't use it, but we have one. Okay, so this is my address. So if I was surfing to Google, well, pretend we don't have a firewall. Actually, let's just say I'm connected to our mail server. It'll be easier. Okay, if I'm connecting to our mail server, the source would be this, because that's my address, 10.60.203.2. Now, if I want to connect, let's find one, and let's look up. Actually, let's find Roy's machine. Okay, there's Roy's machine. And I'll show you my machine again. So you can see both of them on the same screen. I'm at the bottom, 10.60.203.2. Roy, right here, is 10.50.200.30. Okay. Now, you'll notice it shows two different things here. This server is the one that gave me the name. Okay, that's why they're both identical. I did a name server lookup for that IP address. So this is my machine, and this is Roy's machine. Why are they so different? Well, if you look back up here, I keep showing you all kinds of stuff here. This subnet mask here, you'll learn about this in Intro to Networks, but this 255.255.0.0 tells it what part is the network, what part is the host. So 10.60 is the network, 203.2 is the host. So this is my network, this is my host. If we go down here, so again, this is my network, this is my host. This is my network, this is my host. But me and Roy are in the same room. Why am I 10.60 and he's 10.50? Well, the reason is the way our systems are configured upstairs into the switch, we have too many connections. So they actually made two separate networks, but they do make them function as one. So even though we're on different networks, we're really functioning on the same network. And you'll also notice I did this BS13103, but it returned this full entire address. That's the actual machine plus domain. You guys might know this as rows.edu, but we're really admin.rows.cc.ok.us. Very long name. Okay, so those are some addresses. If I was to connect to Roy, say I did ping BS-131-03, I'm actually sending connections to Roy's machine. And if he had a firewall going, he would see the source would be me, the destination would be him. Okay, so that's just one way they're used. Just a little bit about it. Okay, there's source to destination. There are other options, which we don't really cover here, but there's a lot of options for the packets. Then the actual data itself. Okay, let's move on to the next slide. Okay, TCP. Now, a second ago I showed you IP. Now you'll notice we have TCP and IP. I'm looking at. Okay, we covered. Oh, it's covered in Intro to Networks. I don't know if it's covered in this book or not. But the Internet Protocol is called TCP IP. In other words, it uses TCP, that top figure, along with IP. IP handles the addressing. Think of that like the Postal Service. Okay. When I address an envelope, that's what this is right here. That's what the IP is. I put the address on there. I put my return address on there. Put my return address on there. But does IP really make sure it gets where it's going? No. All it is addressing. Now TCP, on the other hand, that worries about did it get there or not. That contains the ports, it has sequence numbers, acknowledgments numbers, all kinds of stuff like that. And sequence numbers is a random 32-bit number that we start, we pick one randomly, and then every packet we send, it gets incremented by one. That way we can tell, we can put the packets all back together again. Okay. We have some pointers: urgent, acknowledgement, push, reset. S is SYN, and then FIN. So there's some different flags there in the fourth line down. Then we have window. Sliding window, that's actually covered in another class as well. But it's how much data can be sent at one time. And yet another checksum. Okay, we have an urgent pointer. Then we have some options data and some more padding. Now we got UDP. Okay, so really we have TCP and UDP. Both of those work on the internet. You have TCP IP or UDP with IP. Okay, you can't have TCP and UDP both in the same packet. It's not going to work. Okay. So a little bit about UDP. Let's actually compare the difference between TCP and UDP. Okay. TCP has source and destination. So does UDP. TCP has sequence and acknowledgement. UDP doesn't. Why not? Well, UDP doesn't care if it makes it there. UDP is what's called the connectionless protocol. And it's kind of like video streaming. What happens if you miss one packet in a video stream? Whatever, it hiccups a little and you continue on watching. Can you imagine if every video packet out there had to be, verified? Like Netflix, instead of just streaming a movie to you, they'd send you one packet, then you had to say, I got it. They send you another packet, you say, I got that one. So in other words, it'd be twice as much traffic. Now they just send groups of data, and then you just get it the best you can. Yeah, there are some checkings, like checksums and stuff built into it, but it's not nearly. You'll notice UDP is a lot less in detail than TCP. Alright, Here's a simple firewall rule. The source, destination, any, and deny. That becomes the top line here. This says, so if a packet comes from 172.16. something something and goes to 10.10. something something with any protocol, deny it. The reason is 172.16 is an internal address. Okay? It's a private address, will not route over the internet. And if someone's using that address, they shouldn't be. It won't work over the internet. So we're saying if a packet arrives from that address, deny it. Again, we're not really seeing the whole configuration, so we don't know all of it, but I'm assuming that's what they're doing here. Okay, then the second one down, 192.168. So if it comes from 192.168 and it's going to 10.10.10.25 on HTTP, which is internet or web traffic, allow it. If it's coming from 192.168.0.1, go to 10.10.10.10 with FTP, allow it. So this is just different examples of things to allow. Okay. All right, application gateways now. It says frequently installed on a dedicated computer, also known as a proxy server. I actually talked about that in the last lecture, so if you didn't read it or didn't watch it, you should go listen to it. But they're used to basically handle the connection for you. So since proxy server is often placed in an unsecured area of a network, like a DMZ, is exposed to higher levels of risk. Yay! Okay, so really what happens is application gateways handle applications. You make a connection to it and say, I want to surf the web. And it looks at that and says, rather than just looking at the individual packets, it's actually looking at the applications themselves and making decisions based on that. You can kind of think, I don't want people to be able to surf the web. So we could very easily block it with an application firewall. Okay? It says additional filtering routers can be implemented behind it, but that's what a gateway does. Okay, circuit gateway firewall. It says operates at the transport layer. It says like filtering does not usually look at data traffic, but it does prevent direct connection. So what that's talking about, so we have two different networks. We're connecting with a circuit gateway firewall. We let a tunnel of data through there, but we don't let anything else through there. Like the third bullet, accomplished by creating tunnels connecting specific processes or systems on either end of the firewall and allow only authorized traffic in the tunnels. So maybe we have two mail servers, on different networks talking to each other. Or maybe we have a web server connecting to an internal database server. Okay? We have a tunnel between the web server and the database server, and the only type of traffic that can go through there is database traffic, nothing else. So maybe logging into a website and it has to authenticate you or something. So the rest of that doesn't happen. Okay, it won't let anything else through. It only lets what's supposed to go through there. Okay, MAC layer, media access control layer. It says designed to operate at the media access control layer of the OSI model, which I think they show us again here in a second, even though you should see that in another class. It says able to consider specific host computer's identity in its filtering decisions. Now, rather than just based on ports and destinations, stuff like that, now we can look at individual hosts. Now, I'm going to say this. Your IP address is your address, but that can change. Your MAC address never changes. Okay? So, your IP address we saw on my window here. Let me show you that again in case you missed it. Okay. I brought up a little more information this time. So here's my machine right here. 10.60.203.2. Okay? That's my IP address. Today. Well, it probably will be for a long period of time. But that can change. Okay? Now my physical address up here, this F04D A20C6BAA, that is actually a hexadecimal address. That's considered my MAC address. Okay? So, let's continue on. It says MAC address of a specific host computer are linked to the ACL. So rather, again, instead of linking or allowing based on IP, now we can base on MAC address. You can kind of think of it like if your router supports wireless filtering, you can only allow certain people through. So that's kind of what I'm talking about. Okay. All right, here's the firewall types. We've got the application gateways, obviously work up the application layer. And actually, if you remember anything about the TCP reference model that you learned about in Intro to Networks, the top three really get combined. Okay, so the application layer, application gateway firewalls work on the top three layers. Then we have circuit gateway. Then we have packet filtering and MAC layering. So why doesn't MAC layering firewalls work at the top levels? Well, because they don't care about the MAC address. MAC address is way there down at the media itself. Okay. Hybrid. It says combine elements of other types of firewalls, elements of packet filtering, proxy servers, all into one. Okay. It could be two separate firewalls working together. It could be one that does both. It could be all kinds of different stuff. Okay. Now it's talking about generation. It says first generation were static packet filtering firewalls. They only filtered based on packets. You know, the whole source destination protocol. Okay. Second generation were now application layers because they found out people could actually do stuff over different ports. You know, I brought up this web page over here, and I showed you dewey.mine.new on 8080. So, in other words, I'm surfing the web to my house, but on a different port. That port is not meant for that. But what I did is I routed internet traffic over a different port so I could see something. Because my house at Cox, I have a home system now, and you can't connect to your home system on port 80. So I reconfigured mine to allow, let's see, I load that one through there. Let's see if we can get another one to come up. This one might take a little bit. Oh, come on. You can load. It's trying. Well, maybe it's not good. Okay, but I have a couple different things working at my house, and I'm not sure if this one's still on or not. It might not be. But I use a couple different ports to connect, so the packet filtering wouldn't be good. Because if they wanted to block web traffic, they block port 80. But I don't use port 80 to connect to my home system. So they would have to block more ports. Application layer are the newer ones. They actually block based on the application. They block web traffic, but the port can change. Okay? Okay, third generation, stateful. Again, do you have a connection already? Okay. Fourth generation are the dynamic ones. It says allow only packets with a particular source destination and address to enter, but they're dynamic. Okay. Then we have kernel proxies. They're built into Windows, stuff like that. Okay. All right. Here's a state table entry. Okay, this source address on port 1028 going to this destination on port 80. So just by reading this, I would say someone in the internal network of 192.168.2.5 was surfing the web on port 80, connecting to the machine 10.10.10.7, okay, using TCP. Okay, that's how you'd read it. All right. Now, let's talk about by structure. It says most firewalls are applications, which actually we're going to see a picture of them here in just a second. At your house, you probably have a router, a Linksys router. That's really a firewall as well. Okay, there's commercial grade, there's small office, home office, there's residential, and here's a picture of some of the small office, home office. You got a Cisco in the bottom right, SMC, Belkin, and I can't read the top right. But they're actually pretty simple to set up. I set up a Sonic Wall firewall for a customer in Oklahoma City and Fort Worth. He wanted to have a VPN, which we'll talk about in a little bit. He wanted a VPN between the two. So he bought two Sonic Walls. I configured both of them right here. Plugged one in Oklahoma City. He drove the other one down to Fort Worth, plugged it in. It works instantly. So they're really super easy to use. And they work great. Okay. Software versus hardware. Which one's better? Well, hardware is always better. Always, always better. Okay. It says, which type should you use? Where would you rather defend against the hacker? The software means they're already in your machine. They've gotten into your machine. Now you're hoping a piece of software can stop them. What happens if they disable the software? So hardware, on the other hand, keeps them out at the door. They didn't even open the front door. Okay. It says, with hardware device, even if the hacker manages to crash the firewall system, you're dead. They're not going to get through. Whereas a software base, if they crash that, then they're in your system. Okay, different firewall architectures. This can be configured in a number of network connection architectures. Okay, we're going to see pictures of them here in a second. Okay, and it's really what do you need to do? What are you planning on do? Where should you put it? Okay, and they talk about packet filtering, screen host firewalls, dual home, screen subnet. We're going to see pictures of those here in a second. Packet filtering routers. It says most organizations with internet connections have a router serving as an interface. That's exactly what we have. Well, at least for the network upstairs. I think row state might have a firewall on the outside, but I'm not positive. Okay. Many of the routers can be configured to reject packets. They do not allow into the network. Okay. Includes a lack of auditing and strong authentication. All right. Here's a picture of a packet filtering router. Packets come in from the left side. Okay. Hit the firewall, and the firewall says, "Whoa, hold on a second." It inspects them, lets the trusted ones through, and turns the other ones away. Okay. That's all it does. Pretty short and sweet. Now the problem is some of these systems, like when I initially had my ISP running in my house, I had Cox, and they provided me with a free router. Yay, but it didn't support any filtering. So basically it was let everything on through, no matter what. That didn't last very long, so I had to get that replaced. Okay. Screened host. This is combine packet filtering with separate dedicated firewalls such as an application. Okay. This allows to pre-screen packets to minimize traffic load. Actually can reassemble the packets and view them. See, a big issue, a lot of people will, the internet, like when you go to the grocery store, you have a big old pile of groceries. It's broken up into separate bags or packets. And if you inspect each one separately, if you go to the grocery store, spend $200, and I look at one bag, well, I have an idea of what you bought. Well, a very small idea. But maybe there's no frozen food in there. There's no dairy, so I don't really know what you got. Okay? Well, with Screen Host, it can actually reassemble the data and then let it go through based on that. Okay? There's a darn fly in my office. It's killing me. Okay. There we go. We got our untrusted packets again. Hitting the firewall. Now, we can let certain stuff through. We can also, based on what's happening, like here they have a Bastion host, we could let certain applications through as well. Okay. So not only do we have the ability to filter, applications, we also filter by packets, and we could, function as a proxy server as well. So kind of handy. Okay, dual home, also known as Bastion hosts, usually have two network cards. I don't think they show us a picture of this one, but it says contains two network interface cards, one connected to an internal, one connected to an external. Implements something called NAT, Network Address Translation. What that is, we actually saw a picture of a state table. That's pretty much what it is. Like when I surf the web, if I surf the web, I'm going to Google, okay? My machine connects, actually, I can't do it. I can't connect, look, it's not going to work. Let me just show you this. If I do a name server lookup for Google, Google has a lot of addresses. It's called round robin, which you learned about in other classes. But if I want to connect to Google, not ping, 164.58.87.35. Okay, I want to connect. I'm saying a ping. That ping stands for Packet Internet Groper. I'm sending a packet to Google, and it's coming back. Problem is, it's not getting there. Okay, now if I do trace route Google, what happens is the packet hits our firewall. Then it's not going to go much farther. It's going to stop right about maybe one more hop. No, I think that's it. What happens is our firewall won't allow it out. Okay, it says, hey, you're trying to check for connectivity, so it's not going to allow it out. But does that mean I can't get to Google? Let's find out. I can get to Google just fine. So how come I can get to Google there, but I can't get to Google here? It's because we block certain types of traffic. Okay? And network address translation, my machine makes a connection to our firewall. And says, all right, Ken Dewey wants to go to Google. So it creates a state table that says, okay, Ken Dewey wants to go to Google. So it keeps track of my packet. It forwards it on for me to Google. When the reply comes back from Google, it says, oh, that's a reply to Ken Dewey's packet, then it forwards it on to me. That's called network address translation. The outside world never sees me. Okay, let me show you another thing here. Yeah, we saw my IP address. It's what? 10.10.60 dot some or other. Who's the address there? Wherever it went. Where's my address? Come on. 10.10.60. No, sorry. 10.62.03.2 is my address. There's a website called IP Chicken. I like it. It tells you this is your address. But if my address is 1050. Whatever the heck, then why is this my address? Well, because that's the address of our firewall, of our external, router. If you were to do this IP chicken from mostly any machine on campus, not every machine, but mostly, if you do it from the cyber lab, it'll be different. But mostly any machine in normal labs or normal offices, this is what you get for an address. We all go out as the same address. So to the outside world, that's my address. But this is really my address, is 10.60, so it's a little bit different. Alright, so we talked about NAT a little bit. Alright, reserved non-routable addresses. You learn this in Intro to Networks, but there's some addresses that you cannot route. The 10 range, okay? That's non-routable. The 172.16, 192.168, those are non-routable. These are what's called private addresses. That's why if you have a home router, you probably have it configured with this 192.168. something address. Okay. At work, we use 10.10. Whatever the heck. So, it really depends. But those are non-routable addresses. Okay. Here's our dual-homed host. It's a system with 2 network cards. Okay. It has 1 external, 1 internal. It does NAT, does all kinds of stuff, and they're just putting all kinds of stuff in these pictures that don't really need, but that's fine. Okay. Now, we have a screen subnet firewall is the dominant architecture used today. So it's commonly used on 2 or more internal bastion hosts, packet filter routers, each host. Okay, and I think we have a picture of them. Well, maybe we don't. Okay. We have a connection from the outside. It's routed through an external firewall. Then they are routed onto a routing firewall internally to the DMZ. Actually, yeah, they're not. I wish they'd show us a picture of this one. Then there's also a connection to a trusted network on the inside. And they're not going to show us it, but what they're saying is maybe we have a mail server and a web server internal to our network. So we want it so traffic can come into the mail server and the web server from the outside world. Okay, that's it. Okay. They protected DMZ because they're only going to allow mail traffic and web traffic in, but they are allowing some in, but they're blocking everything else. And it's also there to protect the internal network. Okay, it could also be called an extranet. Okay, SOC service not used as much anymore. Okay, says is a protocol for handling TCP traffic via a proxy server. You saw it a lot way back when a lot of people were downloading stuff. Actually, there's a lot of people are now, but it's now done through torrents or P2P. Okay, a little bit different now. Okay. There's our screen subnet. So we have our external router. Then we have a dual host system letting certain information into the DMZ. That's this guy right, where's my mouse? Right here. So basically the packets come into this router. They might let a whole bunch of stuff in. Okay? And it hits here and it says, okay, you are for the mail server, go over here. You're for the web server, you go here. You're for the whatever, you go over here. And then the rest of the traffic is even filtered more on into the network. Okay. Okay, selecting the right firewall. Number of factors. I don't think they have the correct factor on top. Oh, okay. They say consider a number of factors. Which firewall offers the right balance between protection and cost? The issue is most people go with the second one, the very bottom bullet first. They go with cost. Home users, yeah, Linksys router firewall is fine. I actually tried to do a project using a Linksys router here at Rose State. Yeah, it lasted about 5 seconds. Once the students hit it with about 40,000 packets, it was done. Okay. All right, what comes with them? Okay. How easy are they to set up and use? Can it grow? Okay, and again, cost would be the next one. Okay. It says they each must have their own configuration. Okay. Must have a policy configuration to keep it. This is firewall policy configuration is usually complex. I do not have one handy to show you, but I'm sure you'll see one in one of the classes. I know you do. I think it's SSAC or one of those you set one up. Okay. Or maybe it's network security. Okay. Actually, I can show you. You know what? I can kind of show you one. Okay. Okay. Come on. There it is. Okay. I set up. I'm showing you my routing table right here. Okay. This is not a firewall, but it's similar. Okay. It's telling you how to get one place, how to get from one place to another. And I don't have any persistent or static routes on here. But this is kind of what you would see. I think
Doesn't Windows have a firewall? I think it's turned off on our machines. Hold on. There it is, Windows Firewall. Open up. And actually our firewall is off, and I probably won't be able to get into ours. Oh, no, they block ours. I can't get in there. No, they don't allow us into ours. They handle it at the domain level, so that's a little bit tough. But one of these classes you'll be able to see. Yeah, see, they're blocking it. All right, so I'll have to show you to at another time. Okay. So it says configuring firewall policies is both an art and a science. Actually, no. Hold on, let me pause this for a second. I might be able to find one. Sure enough, I was able to find one. Okay, I got a couple different ones. I got one for a router here, and I got another one for a router here. This is a ACL. I don't know which router this goes to, but here we're denying certain things, and we're denying everything. So this is only a portion of it. Great. Okay, now there's some permits in there. Okay, let's look at this short one. It'll be easier to see. Okay, remember on a couple pages ago we saw that 172 address. So we're saying deny 172.16 going anywhere. Okay, actually this is a Cisco wildcard mask, but don't worry about that. Just ignore that part. But deny this address. And it says deny this address and deny this address. Why would I deny this address? Well, that's the automatic IP addressing built in Windows. Okay. Then we're going to deny this address. We're going to deny a blank address. Deny a local loopback address. Deny a subnet address. Okay. Then pretty much deny anybody going to 0. Deny anybody going to 127. Anybody going to 255. Then deny. Now this is a weird one. Okay, why would I be denying? Now this was configured on a network in this range. Okay. When I ran my ISP, that was my IP range. So why am I denying that IP range? Well, the reason is, my internal network was 66.210.181. So I don't want traffic coming in from 66.210.181. That's already internal. So I would not let 66.210.181 inside because it's already inside. So now I would let it out, but I wouldn't let it in. Then I say permit ICMP any. That basically says allow ping, that thing I did a second ago, from anywhere to anywhere. Then permit IP any. Now you notice I'm blocked. Actually, this is not set up correctly, but this is actually really old too. I'm denying a bunch of stuff and then letting other stuff through. Let's look at this other one. Okay, so I'm denying a bunch of stuff. I'm denying specific ports. Remember I mentioned initially how my network was set up to deny the bad stuff and let everybody else through? That's pretty much what we're doing here. We're denying all this bad stuff. Okay, we're denying 135, 137, 139. That's NetBIOS type stuff. So we're denying all the bad stuff. We're denying Windows Active Directory. We're just denying all kinds of stuff. But then we allow everything else through. Okay, not really a good plan. And do I have a third one? Maybe a one with a little more information. No, because this is before I did it. Okay, but really I'm denying all the bad stuff and allowing the rest of the stuff through. And I did change mine years later. Actually, it's years ago now. But that's just an example of what they kind of look like. And if you do them in the wrong order, and actually those things there, I don't think I have another one. No. If you put these in the wrong order, they can really cause issues. Like if I was to put this permit line right here, way at the very top, everybody will get it no matter what. Because this is a filter. The first thing that it hits, then it's done. It doesn't, like if you match this line, it doesn't continue checking anything else. Once you hit a line you match, you're done. Okay, it kicks you out or does whatever it's supposed to do. So if I had that permit line at the very top, then you're in no matter what. So managing them is actually, like I said, an art and a science. It says, when security rules conflict with the performance of business, security often loses. Think about it. We want our network to be secure, but it's darn slow. So what's going to happen? We're going to speed it up a little. Because that thing I just showed you had quite a few rules on there. Every packet that came in has to be checked against every one of those rules. Kind of tough. Okay? Alright, best practices. All traffic from a trusted network is allowed out. What that means, like at row state, internal traffic should be allowed out. Now, we don't allow everything out, but that's a best practice. Okay. Firewall device never directly accessible from the public network. You should not be able to configure the firewall from outside. Okay. SMTP, which is email, okay, is allowed to go through the firewall. And we don't do that here, but again, we have some special rules here. ICMP traffic is denied. That's that whole ping thing. I showed you. Actually, I think I pinged Roy's machine. Didn't I do that? Where did I ping Roy? No, I guess I didn't. Let's go ping BS-131-03-T. There you go. Now I'm pinging Roy's machine. It's going to ping forever until I stop it. So what's happening is I'm sending a connection to Roy's machine, and he's replying back, got it. Sending him another one. Got it. So what happens if 1 million people were pinging Roy's machine right now? He'd be having to answer 1 million phone calls, or his machine would. So that can really kill a network. That's where that whole thing we showed you, I think it was last chapter, when we talked about zombies and stuff like that. Okay, so really you want to block that. You don't need the entire world to be able to do that. Telnet access should be blocked. Why would we block telnet access? So, well, first of all, it's to internal servers. First of all, telnet's very unsecure. SSH should be used instead. But you really wouldn't want someone telnetting or getting access into a server from the outside world. Okay, when web service is offered outside the firewall, HTTP traffic should be denied from reaching the internal network. So if you had a web server, then web traffic should be able to get into the web server, but not into the rest of the network. Okay. Okay, it says firewall rules operate by examining data packets and performing comparisons with predefined logic rules, kind of what I showed you a minute ago. Logic based on a set of guidelines most commonly referred as firewall rules, rule-based, or firewall logic. Okay. Most use packet header information, just like I showed you in those 3 examples. Okay. Here would be our example configuration. We might have an external router with an external... Why are the IPs on the same network? Okay, that's weird. External IP and internal IP. Oh, because they have an internal router over here. That's why I was confused there for a second. We have an external packet filtering router and a switch, so he's going to block some stuff initially. Then certain things are going to be able to get into the DMZ zone. Then it's going to hit the internal router. And the internal router, again, the external address is going to match us on the same network as all this stuff. But the internal IP is different. The internal IP is 192.168, all these 192 addresses here. Okay. Now don't be confused, because we did say 10 is a private address, but for this example, just go with this. Okay. So that would be an example configuration. Okay. Well-known ports. Very important. You need to know these. They're on multiple tests, multiple classes. They're just something you need to know. Echo's port 7. FTP is 20. FTP data is 20. And FTP itself is 21. Telnet is 23. We have SMTP is 25. DNS is 53. Let me tell you a little story about DNS. I installed the wireless networks for many of the Buffalo Wild Wings around the city. And they paid me to install them, and I did it, and actually managed them for years and years. They were sending me a check every month for managing it, but with never calling me. So I felt bad and stopped billing them. I felt bad taking their money without doing any work. But when I configured them, they wanted people to be able to surf the web, and that's it. So I pretty much blocked everything but 80 and 443. 443 is the SSL. It's Secure Web. So I blocked everything but 80 and 443. Didn't go so well. I was like, why can't I get on the internet? Well, because DNS is the name service. Remember I did that NS lookup command? That's what resolves names to numbers. And I was blocking that. Whoops. So once I said, oh, wait a minute, I need to allow 53, 80, and 443, then everything worked fine. So it was kind of funny. Okay. POP3 is for email, not used as much anymore, but it is still there. SNMP, Simple Network Management Protocol. Okay. Here's some inbound rule sets. Again, I showed you mine already, but this is just examples. Again, this works as a filter. You can hit rule 1, then rule 2, then rule 3. Okay, and so on and so forth. So, and once you hit one, you're done. Okay. The way you read them is the source port, destination port, and an action. Again, this is not Cisco. This is just a textbook version. But in the real world, they vary by the hardware you're using. Okay. And then here's an outbound rule. Okay. All right. Content filters. says software filter not a firewall that allows administrators to restrict certain content. I do not want you to be able to surf Facebook. I could add that to the content filter. Stuff like that. Okay. Excuse me. It says it's essentially a set of scripts or programs restricting user access. I mentioned it way back when I was teaching up at Meridian Technologies. We surfed something that made it go off, and then someone freaked out. Okay. But it's used, to stop people from surfing stuff they shouldn't surf and stuff like that. Okay. Protecting remote connections. It says installing inter-networking connections requires leased lines. Okay. Normally you're going to get them from Cox, from AT&T, from somebody. So I want to have a connection from here to Fort Worth. How am I going to do it? I could run my own private line down there, but that's going to cost me millions of dollars. So the easiest way is to get internet on both ends and have a secure connection between them. That's called a VPN. Okay, and which we better talk more about that in a second. Okay, let's talk remote access. We could have unsecured dial-up connections. It says attackers can use a device called a war dialer. You've seen the movie War Games. If you haven't, you really need to watch it. It automatically dials all the phone numbers. Okay, and they in the movie they finally connect into a computer and start playing games with it. Okay. All right. Some technologies. We have Radius service, which was remote access dial-in user service, if I remember right. And TACAS, it's like terminal area control command. I don't know. I can't remember the darn names of them, but it's on the next page. And then CHAP and so on. Okay. So Radius, there's remote authenticated dial-in user service. I was right. Yes. Allows you to log in. When I ran an ISP and actually worked for an ISP, we had people with dial-up service. They would dial into our Radius server, we would authenticate them, and then we'd allow them on the internet. Okay. TACAS, Terminal Access Control. Terminal Access Controller Access Control System. Why can I not remember that? So Terminal Access Controller Access Control System. Validates your credentials at a centralized server like Radius based on client server. Okay. And there's a picture. Yay, I'm glad we got that wonderful picture. Okay. Kerberos. Hopefully they go into VPNs. They might not. Maybe it's on a different chapter. Okay. Security authentication with Kerberos. This provides secure third-party authentication. That's what we're actually using here at Rose State. That's what Windows domains use. It was originally designed in Linux. I think Kerberos is like three-headed dog or something like that. Uses symmetric key encryption. We have an entire chapter on that. So we'll cover that later. It says keeps database private keys for client servers, and it handles authentication, or it has an authentication server, key distribution, and a ticket granting system. Okay. Here's how it works. The user logs into a client machine. The client machine encrypts the password to create a client key. The client machine sends clear requests to the Kerberos ticket granting server. The server returns a ticket basically saying what I can access. Okay. That's how we do it. Okay. Now, we're not going to go into all those in depth. There's too much. Okay. Sesame. That's Sesame Street, Big Bird? No. Secure European system for applications in a multi-vendor environment. Whew. Wow. It handles logins under multiple different systems is what it is. Okay. It handles authentication, then allows it across different systems. I'm not going to... Oh, here we go. We have 2 pages of VPNs. Okay. VPNs. Private and secure network connection between a system uses data communications capability of unsecured and public network. In English, it allows 2 networks to connect over an unsecured system. Okay. We have trusted, we have secure, we have hybrid VPNs. I sure hope they go into more in depth on this. Okay. VPNs give us encapsulation of incoming and outgoing data. In other words, you want the data between the 2 sites encrypted so people can't see it. We want it encapsulated, they can't see it or anything. It says encryption of incoming and outgoing data. Okay. So encapsulation is like it's hidden. You don't know there's any data there or what the data is, and it's encrypted. Okay. Once you have authentication, remote computer, and perhaps remote users as well. The systems might, you might provide authentication of users or the systems themselves. Okay. 2 different modes: transport mode and tunneling mode. Okay, let's talk about this one first. Transport mode says data within the IP packet is encrypted, but the header information is not. So what transport mode does, I know there's something going from point A to point B. I know there's something going there, but I can't see it. It's inside the truck and the doors are closed. So I have no idea what it is, but I can definitely see something's going on. Okay? So it allows users to establish secure link directly with remote host, encrypting only the data contents. Okay? It's used for end-to-end transport, remote access workers, stuff like that. Okay? There's again talking about transport. Then tunnel mode. Okay. Now, with tunnel mode, we have a connection between A and B, and it encapsulates or encrypts everything. So the organization establishes 2 perimeter tunnel servers. These servers act as encryption points, encrypting all traffic between them. The benefit of the model is that encrypted packets reveal nothing about the destination. I don't have a clue what's going on. I can't see, other than it's going from A to B, I can't see how much data. I can't see anything. Okay? ISA server does that, but again, I've done it with a hardware-based system. And here we go. Here's our picture of that. We got VPN servers over an untrusted network. They hide everything between them. All right. That's the end of chapter 6. Hope you enjoyed it. And we'll do another one here in a little bit.